Hello everyone, welcome to this video. I hope this video finds you well. In this video, we are going to discuss about advanced CMOS stick diagram. Now, I have already discussed this stick diagram, but why we will go for advanced one? Because this is okay for writing in exam and getting a number, but this stick diagram is not equivalent, or it's not as much as close to our layout, and for that purpose this type of stick diagram, which is a industry standard, or we can say that advanced stick diagram, is used. And this type of question maybe interviewer can expect from you if you have worked on layout, or if you have learned any of the things regarding the layout. So in this video, our mainly target would be to understand how we can shift from this stick diagram to our advanced one, and this require a basic knowledge of our layout, which we will see in the further video. But just to conclude and summarize this previous things which we have learned about the DPP logic, which is like daily practice paper. So D stands for dot, P stands for PMOS, and P stands for parallel. So if there is a dot and we have to construct a PMOS logic, it will be done in a manner of parallel. Now, when it will be applicable? When we are doing the equation in the form of y bar. So if my question is y is equals to a dot b bar, which is equivalent of NAND Boolean expression, so y bar would be a dot b. Now this should be implemented with this concept of DPP logic. So as you can see, there is a dot, and I have to construct the PMOS. As in the CMOS, the upper network is the pull-up network, and it is constructed with the help of PMOS, and the lower one is pull-down network, and it is constructed with NMOS. So when I go for NMOS, then this parallel will change into the series. So this type of concept I have already discussed. So A and B in PMOS will be connected in parallel, and here they will be connected in series. As you can see, this will be the source, this will be the drain, this will be the source, this will be the drain. So they are both sharing their sources and connected to VDD. Similarly, their drain are also shared, and this one, this is drain, this is source, this is drain, and this is source. Again, how to know in a transistor whether it is a drain or it is a source? So this type of video I've already covered in my previous videos, so you can check in the detail. Because interviewer may ask, they can give any kind of voltages. Suppose there is VDD and here VDD plus 1 volt, so they can ask like this: what is the drain and what is the source? Suppose it is a PMOS, or it can be NMOS. So our basics should be strong and our fundamentals should be clear. Now this type of CMOS stick diagram, I already told you, like this A and B, they are in the parallel, so we will create a line like this. Basically it's representing the diffusion layer, and this A and B would be created in this manner. For simplicity, it is in the parallel, and they are in the series, so it will be constructed on the same line like this. And to connect between them, a metal will be used, and V out, or you can say that Y, equivalent logic will be used here. I can write like Y. So this is all about what we have learned earlier. Now what we have to learn, we have to learn how we can represent in this way, and this is the more accurate way of representing the layout. Now let's see. So just for your simplicity, so that in minimum time we can cover this, I have written some of the things on my own. So these things represents our previous schematic of the transistors. which stick diagram has to be created, and this thing is basically my boolean expression, or this is boolean logic expression. We have taken y bar and a dot b and again implemented the DPP logic concept. It's not a concept, it's a trick. So and with the help of that we can make this transistor schematic within a seconds. Now coming to the conceptual part, I would like to highlight the structure of the PMOS. Now for the PMOS we use n-type substrate. Okay, this is my n-type substrate, and in n-type substrate what we will do, we do p plus diffusion. Okay, so we do p plus diffusion to create PMOS. Unlike in NMOS, we have a p-type substrate and we do n plus diffusion. Okay, so let's again go to the PMOS back, and there we can see that this is my diffusion thing, and over it we create a polysilicon layer. So polysilicon is nothing but it is used in VLSI fabrication, or in the layout part, which we can say, and it represents the gate. Okay, it is used for construction of the gate. At a higher technology nodes we use polysilicon, but when we go for less than 45 nanometer technology, then we use metal also for purpose of making the gate. Again, that is not the topic of discussion. So main topic of the discussion is this. So this is my p plus diffusion layer, and over a p plus diffusion layer the idea is to place polysilicon vertically. So if I place polysilicon vertically, it will create a gate, and side by side source and drain will be created. Similarly for NMOS, if I am having a p-type substrate, which is my active region, we write it like that, and I am having suppose polysilicon gate again over it, then on n plus diffusions what I can get is source and drain on either of the side. So this is a basic idea which should be clear. Okay, now with the help of this idea only, we are going to draw our Cmos stick diagram, which is the advanced version from the previous one. So this is nothing but this is the VDD and this is a ground. So let me represent it with a blue color, or let it be with in black only, and let me represent my n plus diffusion layer. So it would be represented with the help of a green line, let's suppose. So this is my n plus diffusion, and let me use orange for p plus diffusion. So this represent p plus diffusion. So what happen is, if I have to create a PMOS, then I will put a polysilicon vertically on this p plus diffusion for creating PMOS, and similarly for NMOS I have to create a polysilicon vertical on this n plus diffusion. So if I create a polysilicon here and here, so it will construct my PMOS and NMOS respectively. So this will create my PMOS and this will create my NMOS. So we have already discussed here, please see. Okay, this is p plus diffusion, and one vertical line, it will be equivalent to my PMOS. So same, it will create a PMOS. Now the trick is that A and A, so both logics are same. So one A will be created for PMOS and one A will be created for NMOS, because in CMOS number of PMOS transistor is equals to number of NMOS transistors. So this should be kept in our mind. So if I'm having A above, I'm having A below, B and then B. So doesn't matter there in which way they are arranged, but number would be the same. So this A and this A will get the same logic from A. This B and this B will be get a same logic from the B. So similarly, if they are same, then why not to create a polysilicon layer like this? So this same will be represented A and this will be represented B. So here PMOS will be A and here will be A. So why not to join them? So the idea is simple. We are going to implement like this only. So we will take a polysilicon layer and we will implement like this, thus creating one PMOS transistor here and one NMOS transistor here with using the same polysilicon layer. And here also I can make one more. So this is representing for A and this is representing B. Now coming to the point how we are going to check that whether they are in series, whether they are in parallel. So these two PMOS transistors are sharing their sources in a parallel way and they both are connected to each other as well as to this VDD. So what we will do is we label it. So for source drain I can label like this. So A and B both having source sharing them and they both source is connected to VDD. You can see it from here. So this source and this VDD is connected to it. I hope this much aptitude you might be having. Okay, this is not a rocket science. This is simple. Like this is A, this is B. I have to create like this so that I can share their source as well as I can connect it to VDD. Okay. There is other way also. Here source, here drain, here source. Then you have to connect like on both way. Okay. And then you have to take drain connected and then you have to take. So that is also a correct way, but just stick to one method and one way. Later on we can optimize it and according to the area, according to the source drain sharing, we can optimize it. Okay, so when you read some or go in some more deeper, then you will get to know like this will have a effect on the parasitic specs. So when we do some parasitic extraction, then our delay may be same, may decrease, may increase. So it should increase normally, but it can decrease also due to this source and drain sharing also. Okay, so that is another concept, but for here we are just focusing on the stick diagram, so we should be here only present. So this source is sharing to each other, they are parallel and this is connected to VDD. Similarly for PMOS, these both drains are connected to each other and then Y, which is my output, is connected to it. So let's connect it. So this way my Y will be connected. So both drains are connected. Let me make it a little bit more cleaner. And then this. Now for A and B in the NMOS region, you can see A and B how they are connected in a series manner. So source of A is connected to drain of B. So source of A will be connected to drain of B and drain of A is connected to Y. So this is also very important. So here you can write drain, here you can write source. So you can write like this also, but again you have to write and choose the one which is good for you and doesn't create any confusion. So I am taking my drain here and source here, and here I have to choose drain over here. Here I can't choose source because from the source of A my drain of B is connected and that is in the sequential manner or in a serial manner. If I connect my source over here, then it will be connected in a parallel way. Okay, I hope this much explanation is enough and sufficient, or I don't know, I am over explaining it, but these things should be kept in mind while drawing this Cmos stick diagram. Now what I will do is, my source and drain is automatically connected, and hence A and B are connected in sequential manner, but two connections are remaining. One is this and another is this. So drain of A should be connected to output Y and source of B should be connected to ground. So let me make the connections. So source of B should be connected to ground, and here the drain of A should be connected to Y. So just for a simplicity purpose, I am connected like this. You might be thinking you can connect like this. Yeah, this is also correct. Okay, both way of writing is correct. Ultimately that is single wire or the same wire. Okay, so it doesn't matter you connect like this or this. It's just the length of the wire which got increased, but logic will be the same. So if I asked in the exam, like, you have to make the optimized one, then you have to make like this. But as of now, this also works well. So I hope the idea of making this advanced CMOS stick diagram is clear, and in upcoming videos we can see some more example on it, but I think this is sufficient as of now. So thank you very much.